And welcome back. We are going to go ahead and take our moment to look at an example of an array list and how its implementation can actually be used in the various different aspects of what we've seen. So we're going to look at specifically at something called the score class today. Now this is something that we have seen previously, but it might have been handled with different things such as an array. But we can also do these things with array lists. Pretty much anything you can handle with an array list can also do as well. Now the program scores will read in a list of scores and then output the average of those scores and how much each will differ from the average. The scores are then read and stored within an array list so that they can be available later in the program, whether we want to simply just recall the list of what a particular score is or use it for a different kind of calculation. Now while we could do this with an array, it's much easier and cleaner to do an array list, and there's a couple reasons why. First of all, when we think about how this program works, we're probably going to be a list of values of type double. So, if you think, okay, that's double, that would be an array. Well, actually, we can do this with an array list because we can have the base type double, which is one of our wrapper classes, to actually store those values for us. All right, we did not use an array list with the base type double, as in the primitive type. Notice it's a lowercase d here, because array lists have no base type double. All right, it has to be a class type. Base type, if you have double with a lowercase d, remember that is a primitive type. It has to be a class type or some other type of reference type. So if you did, like, for example, like a string would work because string is a class. Now, I did say that we can use this with doubles because of Java's automatic boxing and unboxing that it does. So we can have an array list of type double with a capital D to store values of type double with a lowercase d. So it will still work, is that we can't create that array list of type double with the lowercase d because, again, remember, that's a primitive type. So how does this actually work? How do we actually look at this if we were to look at this score class? Well, an array list is a very wonderful thing because it'll automatically keep track of how many elements are stored within that array list. We don't need to say, hey, do you have like 10? Do you have 20? How many do you have? Because it's automatically keeping track of that for us. If we had, let's say, an ordinary partially filled array, which is how we could kind of work this program otherwise, we would actually need an extra variable, like such as an integer or a double. Probably an int would be enough just to keep track of a count of how much of that array is actually being used at that time. Is it using 10 elements of that array? Is it using 20 elements of that array? The nice thing is when we use an array list, we are spared from having to do all that overhead programming that's associated with, for example, a partially filled array. Now the code for those details are technically is in the definition of the array list class, and if you want to go dive into the documentation and stuff like that, you're more than welcome to. But we don't actually need to worry about how that actually works because that code implementation is all handled for us with that array list class. As long as we know how to use the array list, we don't actually have to worry about how that's been implemented inside of Java. Now, you'll notice we also are going to have in our code here some for each loops. And you might say, well, why are we using a for each loop and not, for example, a while loop or a regular for loop? Well, there's a reason for that. With for each loops, these are typically the cleanest and easiest ways to cycle through all the elements in an array list because it lends itself really well to how array lists are structured. When we use an array list, it's very clean and even sometimes shorter to do this than if we looked at this with an ordinary array. An ordinary array, we have to use like a for loop or we'd have to use a while loop. Well, the reason why we can use for each loops here is because an array list does a lot of those things that we'd have to manually code up explicitly in an array. Array list does it automatically. All right, this is known as information hiding or code reuse because this stuff is already done for us, so we don't have to go and reuse and pretty much invent the wheel, if you will, for how that array list is being handled. That's because the programmers who actually defined that array list class that we're importing and using in our program did a lot of programming so that the programming task that we are undertaking is a lot simpler than we would have to be. For example, if you look at how we're doing this array list versus how we would look with a partially filled array, you can see that the partially filled array is much more complex to be able to handle versus that of using an array list. Now, obviously, we do talk about how array lists have some drawbacks, and one of those things is they are less efficient. However, we can use something called trim to size to help save on memory resources. array lists automatically increase their size when your program needs them to have additional capacity, which is awesome because it's like, hey, I have 10 elements. I want to add one more. Okay, well, we can go up to size 11. No problem. However, it is something to keep in mind that capacity may increase beyond what the program requires. Additionally, let's just say it needs less capacity in the array list. So you're removing elements out of that list and it's still at the same size. That array list will not automatically shrink. So if you have, let's say, 20 elements array and you took 5 out, even though now there's technically 15 elements in that array, it's still going to be size 20 because it doesn't automatically shrink. Now, if your array list has a large amount of excess capacity, and I'm not talking like, the example I gave like 2015, but let's say something much larger, let's say like 1,000 to, let's say, 600. You're looking at larger numbers here. Well, we can, of course, save on memory by using the method trim to size to shrink the capacity in an array list. So we can bring that size way down to something that's going to be much more efficient. Now, if a list is an array list, because there are other types of lists out there, if we were to, let's say, invoke trim.size here as our method, we can shrink the capacity down to whatever the size of the list. So let's say the number of elements, let's say, is 650, and we have 1,000 elements. We can say trim to size, and that's going to drop that 350 elements that aren't being used down to 650, which is going to save us a lot of memory and resources. Now, just remember, normally we're only going to use trim to size when you know that the array list you're using is not going to need additional capacity later. So, you're like, hey, I'm not going to add any more elements to this array. I just want to have them here. Great, trim to size, save in memory. We'll move on with our life. Now, there's one thing I do want to point out when we start talking about array lists, because array lists are very wonderful, but you have to worry about things like the clone method making things known as a shallow copy. All right, and there are situations when we want to have an independent copy of an array list object. In other words, we want to make what's known as a deep copy. A deep copy, remember, is completely independent. In other words, if I were to have, let's say, an array list of 5 elements, and I want a second array list to copy that over, if they're not deep copies, they're not going to be independent, which means we'll talk about this, but if I change something in one, it's technically going to change it in the other. And the reason for that is that when we define a class, for example, with private instance variables of the array list type, and let's say we want to have an access method that's going to return that deep copy of the array list, the reason why we want a deep copy is because we want the array instance variables that are associated with that. We're not looking to simply just see where it's out in memory. And a lot of people might think, well, if I just want to copy this, I can just use the clone method, right? Or maybe, I can try to use the assignment operator. All right. Well, as we've seen in the past, using the equal sign, or the assignment operator merely copies a reference that we have to another name for the object. All right. It's simply just pointing to where you're storing that in memory. All right. And when we do that, we don't have an independent copy. We have what's known as a shallow copy. And shallow copies, of course, are going to cause issues with memory references. It's going to look in memory and say, hey, these two objects, they have the same name, but they're pointing to the same area in our memory, so they're going to have technically the same values. And if we look at this with an example, let's say pet is a class with all our usual accessor, mutators, etc. All right, we created a new pet class. You can see it says pet list 1 is new array list pet. And then we say, hey, array list pet list 2 is equal to pet list 1. So that is using, of course, our assignment operator. We're setting equal to there. We've seen this kind of fallacy before, where if we try to set an object equal to another object, we are not copying that information over. Instead, we are updating the reference of that object. And therefore, pet list 2 and pet list 1 actually end up becoming two different names of that same array list object. So if I make a change to pet list 1 or to an element of pet list 1, it's also going to affect in pet list 2 and vice versa, because they are technically the same list. Now, as I mentioned in this pitfall, cloning is also a shallow copy, because when we look at cloning and how that ends up working, we can't use it in the way that we might expect. If we tried to say like, hey, I'm just going to use petlist1.clone and clone that element, it's not going to work, because the way cloning actually works, it's going to actually not give us that deep independent copy. It's actually going to give us a shallow copy because of the way the clone method actually is implemented. And the drawback of an array list is there's no kind of built-in method to actually give us a full deep copy or independent copy of that array list. So if we actually want to have a deep copy, how do we do that? How do we actually go making that deep copy? Well, we have to resort to a couple of little programming tricks. So it's a little bit more for us to kind of undertake, but we can do it. If we have a way, of course, to make a deep copy of objects of a base type, then we can technically make a deep copy of each element in the array list and place them into a new array list object. So first you have to go element by element and copy it over. This is the same way we approach making a deep copy of just a regular array. So you think about a regular array, if I have array 1 of index, and we just say index is, let's say, 0, then we look at array 2 and we say we're going to look at its index of 0. We want to set that, so array 2 index is equal to the index at array 1, and then you repeat that for each of those. So it starts at 0 and goes to 1, etc. So we're going to kind of have that same approach here when we deal with array lists. And while this might seem, kind of subtle or maybe difficult to kind of think about, this is nothing that we haven't already seen with a lot of this approach in dealing with any type of class objects. And just real quick, let's just look at the scores class to see how this array list is working. If you look here, we have a array list of type double, just like we talked about at the beginning of our lesson today. And you can see that we're reading in scores and just seeing how much they're differing from the average. And you see we have a prompt here to enter each score, and then it calls two different methods, fill array list and show difference. So in here, if you look at fill array list, you can see that this is, of course, entering a list of 9 negative numbers. And then we once we put in a negative number, it's going to terminate that. So this is a pretty straightforward method, nothing new that we haven't seen before. And then, of course, down here is show difference, which is just giving how much are they different from each element. And you notice it's calling in here compute average. Now, compute average, of course, in here, we could call compute average technically in our main class. And it would technically allow us to have that if we wanted to, for example, put that in a print line statement. We could, of course, call system.out.println, compute average, pass in score, and we could find out what that average is. If we run this program the way it is right now, one of the things you'll see is, okay, enter some scores. And so let's just go ahead and put like 7, 5, 3, and 2. And let's put -1 just to terminate it. You can see we automatically get that average computed for us. So it's actually going to print out the average. So there's not a need for us to have access to this fill array list, or the compute average list here. Because you'll notice in here, it actually is part of the show difference. And so one thing I do want to point out is sometimes when you're looking at your code, you could come back here to this method, for example, unless I want someone to directly have access to it, you could change the access level to this. So for example, if you don't want to be public, if you wanted to change it to, let's say, a private method, because you're saying it's just going to be a helper method, you could do that. But there might be situations where you do want people to be able to grab compute average directly, and so that's why you might leave that as public.